Hey everyone, welcome back to my daily coding series. Today's day 64. I just got done filming yesterday's episode, but I have to do them back to back because tomorrow I'm going to be busy. So yeah, I think what I'll do today is just solve a couple easy problems, just because it's getting pretty late. So I guess I'll just do a couple of these. So let's look at reverse string. Okay, so we're given a function to reverse a string. So we're given a list of strings. Okay, we're given a list of strings, and we must modify s in place. So we can't use any extra memory. So that means, we can't create like another data structure, like another list or something. We have to just use the one that we're given. Okay, so what I'm thinking we can do from an algorithmic perspective is we would have a pointer at the beginning and at the end of the list, and we will swap the characters with those two pointers. And then our left pointer would increase by 1, our right pointer would decrease by 1, and we would keep swapping those characters until L equals R. So I'll say while L does not equal R, or I guess I could say while L is less than R, and we'll set L to 0 and R equal to the length of S minus 1. Then we will swap characters at L and R, and then we will return S. So to swap two characters, we need a temporary variable. So I'll say temp equals S at index L. Then I'll say S at index L equals S at index R, and then we'll say S at index R equals temp. So this will swap the characters. One last thing, we have to make sure we update our pointers. So L will go up by 1 and R will decrease by 1. And I think that is it. So let me try that. Okay, perfect. So that is problem number 1. So let's look at another one, valid palindrome 2. Okay, this one might be more tricky. So given a string S, return true if the S can be a palindrome after deleting at most one character from it. So normally with a palindrome, we use a very similar, like if we want to detect if there's a palindrome, we do a very similar approach, but instead of swapping the characters, we'll just check if they're equal, and if they're all equal, then we know it's a palindrome. In this case, we're allowed to delete a character. Okay. All right. So if we have ABA, for instance, first let me do a basic palindrome check. So it's going to be very similar, and I think that's why it's kind of after this problem. So it's going to be pretty much the exact same code. While L is less than R, L will go up by 1, R will go down by 1, and we're going to say, we'll say palindromic equals, so we'll assume that it is a palindrome, and then if S of L does not equal S of R, then we'll say palindromic equals false, and we will exit. Well, I guess we could just so normally you could just return false here, but I'm just putting it as a Boolean because it might give us some more flexibility for the real solution. Okay, so I'm going to run this. It's not going to work, but it should give me true for this. So okay. So let's look at, so I just did a palindrome check, like a basic palindrome check. So I don't know if it's as simple as like we have to find this rule twice, but if we look at like A, B, C, A, we would say, okay, our left pointer equals our right pointer. We'll move both of them in. We'll see that this is not true. And then our loop will exit. What if we had, let's say, something like this? And I'll just simplify it. Okay. So if we have A, B, so this part's a palindrome. So if we removed one character, would it be a palindrome? So no. There's no one character that we could remove here. So in this case, we'd say, okay, A and A are equal. B and C are not equal. So I'd probably just move up one of them. So it would be like deleting B. Or in this case, we could delete C. So we would just skip it. So I think what we would say is, we'd probably say, I'm thinking it's sort of like lives or something. Tries, what's a good variable? All right, don't overcomplicate early. So I'll call it lives or like tries. So that's, okay, I'll call it lives. So that's like how many misses that we have, how many lives. So we'll start off with 1. So if this is not true, we'll say, so if lives, and we could make it a Boolean, but this would allow us to be more flexible, I think. So if lives is greater than 0, then we can continue the loop. If it's not, well, I guess maybe here we could say if lives is less than or equal to 0, then we can return false. Otherwise, we'll set lives to minus equals 1. So my thought process there is, and then maybe we should set, we should cancel out this. Okay, so my thought process is, so we'll keep checking. So in the case of A, B, C, A, we can delete either C or B. So I'll just delete the right character for now. So, okay, so this would be the same. These would not be equal. So lives so this would be false. Lives is not less than or equal to 0. So then we'll decrease it by 1. And then I would make L go here and then come back. And then R would go here. So the reason I'm doing that is basically just so R would get skipped essentially. So you can think about it like if we had, what's another example where it would work? Probably this, yeah. So if we delete C, then it would still work. All right, this is interesting because in this example, we have to delete C and we can't delete B. So it might not be arbitrary which pointer we skip. Yeah, okay, so we'd look at L and R. And then these are not equal, so I would move R and keep L. And then these are equal, and then we'd be good. In the case where we have something like this, no, that's not right. If we had, isn't this what I just did? Okay. In the case we have something like this, A, C, B, B, A, we'd get to this, and then my algorithm as it stands would move R over, and then we'd compare C and B. So I need to determine which character gets skipped. Is it the one at L or is it the one at R? So how do I know? A, C, D, B. So this is a palindrome, but what if this one is B? So in this case, this will never be palindromic, even if you delete a character. But what if there's a B here? Then in this case, it could be. What if it was B and we delete this one? So A's match, this doesn't match. So we would, okay, so this one's not possible because I guess what we could do is check maybe like if S of L plus 1 equals S of R. So I'm going to go back to that other example, A, B, C, A, and what did I have? I had this, right? And we must delete the right character. So I'm thinking we can look ahead. So if this one, so if we skip the L character, does it work again? In which case we would say, so lives would go down by 1. Well, no matter what, lives goes down by 1. But in this case, that means we should skip L. So we would set R minus equals 1, and otherwise it would be L minus equals 1. So that, like, you know, we want to skip L, or yeah, we'd want to skip L. So that means R should stay the same. All right, let's try this. And I wonder if there's like an index error here somewhere. Okay. Wrong answer. E, C, E, E, C. E, C, E, E, C. So I output false, but the answer is true. So you can delete something. So the answer on what you would delete would be this E here. So I said these are not equal. We don't really need this. Optimizing too early again. Okay. So these are not equal. So lives is fine. Is L of, yeah, so those are the same. So I'm setting R goes to here. Oh, we want R plus equals 1. We want to undo the change. Okay, so this might be wrong still, but all right. What? We're almost there. Well, this is a bit annoying. All right, I'm just gonna cut it like here. So so A G U O K, A G U O K, K pat, K pat. Yeah, this one looks good up until there. Okay, so now we're just looking at this part. So I'm saying that these are palindromes. Okay. So these parts are also palindromes. FPJ, FPGJ. It's also palindromes. DMY, is it like in the middle somewhere? DMYS. So obviously a brute force approach to this would be, you could call it a palindrome check where you delete every character, so you would call it n times, so that would be n squared. GV HM VFFC NQ. Okay, so I've let's say use test case, and if I go back to my code, false detected at L equals R equals. So let's see where it's telling me it is not true, because I went through it, I probably missed something. But let's see. False detected at L equals 19, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. C. And this one goes L U C. All right, let me print S of L and S of R, like so. And let's see, so C and U, and then at 21. Okay, so let's look ahead here. So C and U. So it's this C and this U right here. Or sorry, this C and this U do not match. So then I look ahead and I say, does L equal this one? Yes. So we delete the C. And then what happens? It says P does not equal C. And 81 minus 19 is 81 minus 20. 61 plus 1, 62. And then here it's 61. So the difference decreased, which I would expect. So we detected another false. So let's see. But this is saying it's true. So C and U. Well, in this case, both of them are possible. That's probably the issue. And then it turns out that this one is false, but this one's true. If both of them are possible, I mean, I could do it in 2n. I wonder if there's a better way. Could we maybe try doing it recursively, in the sense that we have a function called isPalindrome. I'm going to try organizing this a little different. So let's have a function called isPalindrome, which takes in self, and it will take in a string. So we're going to set it like this, while L is less than R. Or maybe it could just take in, let's make it an inner function, and then let's, so it doesn't need self. So let's make it just take L and R. Yeah, so I'm thinking then we would say if, like this, L plus equals 1, R minus equals 1. Okay, so I'm thinking, so it's a basic palindrome check. So I'm thinking what we can do for our solution is So palindrome check. What we can do is so maybe we can call is palindrome on 0 and length of s minus 1. So this will say, is the solution a palindrome? If it's not a palindrome, I want to know L and R. So maybe it'll just do, so this function will just do things to L and R, and we can check, so it'll give us L and R, and we can say if L is greater than or equal to R, then we know that the base case has been passed. So if it's not true, then we'll call it 2 more times. So if it's not true, we'll say is palindrome of L L and R. So I'm thinking we could do something like this. So we'd say L plus 1 and then R plus 1. So that's kind of my idea there. So these are like our 2 chances. So if they're not equal, then we'd call it again with wherever L and R was, but we're just going to skip L for one of them, which would be L plus 1, and then R for the other one. And then we would return if maybe we could just return true or false, and we don't have to be clever about it. So we could say return true or false. We could say if this is a palindrome, then return true. Otherwise, return if that's true or this is true. So it's going to calculate both of it. Okay, this is kind of a cool, I don't know if it'll work, but it seems kind of cool. L is not defined. It could be L is not defined. Yeah, that makes sense. So how do we want to scope this? So I could pass it L into R, or I could just pass it nothing. No, you need something. So maybe these should be local, but it does have to somehow impact this. So we could just return like a tuple. I understand, but this seems kind of like ugly to me. But again, don't try to optimize before you're done. So here we would return just -1, -1, it doesn't matter. And we'd say if the first element of that tuple is true, then we can return true. And of course we would do LR here. Otherwise, well, let's say we'd say like P maybe, and then L and R equals is palindrome of this. Right. All right. So we'll call the function if P. So if it is a palindrome, we'll return true. Otherwise, we'll call it twice. And we'd have to say the zeros of these. And then, of course, L and R should be defined now. Let's see if I get any compilers. Invalid syntax. I have a colon. I don't need that colon. All right, let's see. String index is out of range. That doesn't seem... Yeah, maybe it could be, since it's kind of like a global variable, maybe I could say result equals false. Maybe I could say, so now I want it to be kind of like copies of whatever number. So I could say like temp L equals L and temp R equals R. And then I could say if this with temp L plus 1 and temp R, then return true. Then I could say do the same thing. Yeah, the only thing is I don't want... So, okay, so this is a variable, and then it will pass in... So let me just print... Let me make sure that these are the same before and after. So if I print temp L equals and temp R equals... I want to make sure that these are the same before and after. So let's see if that works. Okay, yeah, so I suspect if I return false here, I might get an output error. But I think I can condense this code if they're the same. Okay, we have an error, but it does look to be the same. Okay, so it's false. Is it because this is being changed? So this is not a palindrome. So where was it not a palindrome? Well, it's when B and C. So when 1, 2, 3. So these are not the same. So now I want to check if we pass is palindrome to 2 and 3, or, okay, I did the same thing twice, so that could definitely be causing an issue, because that should pass. All right, we have an out of range error. ABC. So this is somehow getting, so this is false because that does, like, the A and C don't equal. Then it should print, yeah, 0 and 2. Is palindrome 1? Oh, I see. We have to ensure, yeah, let's just add it here. Or should we? So where should we do the out of bounds check? So, where should we do the out of bounds check? I'm thinking here. Yeah, we could just say if, you know, temp R plus 1 is less than length of S, and, you know, so we could just do the bound check here perhaps, because the problem is we got to make sure this one's greater than 0. So yeah, the problem is that we're trying to add 1 to 2, which gets us 3, which gets us the out of bounds. So let's first run it to make sure that error is fixed. Okay, and now we have this. So let me submit it. Well, I guess I didn't have to do that. This one is also wrong, which I feel like it should not be wrong. So 1 and 3. So it's going to call it with 1 and 3. And then now it's going to suggest calling it with 2 and 3. So let me just print here, checking palindrome with L equals and R equals. So it should say checking palindrome with 2 and 3 if I'm understanding my solution. Okay, not that one. Should use that. Okay. So 0 and 4 is not a palindrome, so it's going to end at 1 and 3. Is that where we want it to end? Yeah, 0 and 4 is a palindrome, 1 and 3 is not. So now it'll check it with 2, 3, which is false. And then it will check it with 1. So these were not the same. So it should check it with 1 and 2. So R should be actually -1. Yeah, R should actually be -1. R should be -1, which means, I mean, I could put that. I don't even think that's necessary anymore. So yeah, it was just a logical error. Okay. Yeah. I honestly don't think I need this then, because R will always be going down and L will always be going up. So I think I can... Okay, so now I think I can do something cool. This was my idea the whole time. So palindrome. So now I'm going to do this check. Yeah, looks good. And then we're just going to return if that OR statement is true. So this was my idea. So if either of them are true, so if we skip the character on the left, if we skip the character on the left or if we skip the character on the right, are either of those true? And we must, I believe, do these weird variable stuff. Because otherwise, if we just passed L plus 1 and R plus 1, it would adjust this global variable, I think, but maybe not, because it would go local in scope. So let me just make sure this works. So yeah, it's really fast. Invalid. I have a colon again, so let me double check this. Okay, so that looks good. Now I'm pretty sure if I were to say L plus 1 here and R here and L and R minus 1, I believe this would not pass every test case, because if this modifies it, it would then call this function. Okay, I guess I don't know what I'm talking about. So in that case, this would get called, and I guess it would just modify the local scope L and R. And then when we exit the function, L and R are now in the global scope. So if we said non-local L, non-local R, then this would fail, because this would then be referring to the global scope. Yeah, well, okay. That didn't exactly illustrate the point, but I think I get it. So we don't need this anymore. We don't need this print statement. Do we need this weird janky stuff? I feel like we do because we need to know where L and R fail. It's kind of super janky, but the reason I'm thinking about it like this is because this tells us where it failed, and then we can use that to know where to skip. But the tuple stuff is a little janky because then we have to do these zero indexing. And then this -1 doesn't make any sense at all. So, I mean, could I do, will this work? Will this be recognized as a tuple or a Boolean? Yeah. I could say tuple true, but this looks even worse. It doesn't even work. Okay. All right. Okay. So yeah, it's a cool idea for sure. There must be like an easier way to do it probably. I mean, there has to be, but I thought this was cool. And it looks pretty fast, I guess. This graph, to me, okay. So I guess all of the other entries are not on this graph, and they're to the right of the graph, but okay, yeah, so that's valid palindrome 2. I want to see, yeah, I've never really looked at LeetCode solutions before. I usually just do it on NeetCode, but yeah, is there a way to see the acceptance rate of this problem? Yeah, maybe if I go here, it will tell me. Is that going to do the same thing? Yeah. Okay, valid palindrome 2. Because that one felt a little bit harder to me than most easies, but I think that's another thing too. Okay, yeah, I had a pretty low acceptance rate, but so does valid palindrome. Yeah. That's another thing with a lot of easies is I feel sometimes you'll get a really easy one and sometimes you'll get one that's a little bit more complex. So they're a bit different in scope and difficulty. But anyway, so I will probably just title this video Valid Palindrome 2, and then this will just be like a little warm-up problem. But yeah, so thank you guys for watching. Today was day 64. And I will upload day 65 tomorrow. So thank you guys for watching, and have a good day.